Alright, so in this question it says that we need to, it says the diagram shows two circles with centers A and B having radii 8 cm and 10 cm respectively. The 8 cm the radius is the smaller circle and 10 cm the radius is the larger circle. The two circles intersect at C and D, where CAD is a straight line and AB is perpendicular to CD, right? The first part, find angle ABC in radians. So this is pretty easy. You can see that we need to find this angle ABC, right? And this is a right angle triangle. This is 90 degrees, right, which they have mentioned. So what I can do is I can do sine of theta or sine of A B C equals to opposite of hypotenuse, 8 by 10. Now be sure to put your calculator in the radian mode, because they have asked you to find the angle in radians, not in degrees. By default, calculator is in degrees mode, right? So you have to convert into the radian mode. So we'll get ABC equals to 0.927 radians. Now on to the second part. In the second part it says find the area of the shaded region. Yes. So now let's plan a little bit. How can we find the area of the shaded region? The shaded region is part of the smaller circle, right? So to find the area of the shaded region, what I'll have to do, I'll have to subtract the whole area of the smaller circle from this region, this one. Alright, so let's name this region X. Like this is my region X. So the area is shaded area is area of smaller circle subtracted with area of region X. Now let's find the area of region X. Now as we can see that the area of region X, consists of a segment of the larger circle with the radius 10 cm. So what if I find the area of the segment of BCD, right? What if I find the area of this segment BCD and subtract the area of this triangle BCD from the area of the segment? I'll be left with the area of this region, right? Of this region. Then I'll add the area of this part, which is half of the smaller semicircle, into this region. Let's name this region V, right? So I'll get the area of region X. Then I'll subtract the area of region X from the area of the entire smaller circle. Alright, get it? Now let's find the area of X. This was area of segment BCD subtracted from area of triangle BCD added to area of semicircle, right? So area of segment BCD is this. This is BCD segment. This is the area of segment BCD. I'll subtract the area of segment BCD from the area of triangle BCD, right? This triangle. I'll get the area of this region V. Then I'll add the area of V into the area of the semicircle with the radius 8 cm. Alright, so let's carry on. So this will give us area of segment is half r square theta, right? So half r square theta. For triangle, I'll use the formula half into side 1 into side 2 into sine the angle between them, sine theta, plus area of semicircle. So I'll do pi r square over 2. Okay. So r is for the segment r is 10, right? And for the triangle, the sides are also 10. So 1 by 2 into 10 into 10 into angle was 0.927 radian. This was 0.927 radian, and this will also be 0.927 radian because it's an isosceles triangle. This 10 equals this, right? So this angle will be equal to this, and this 8 will be equal to this 8, right? So the total angle CBO will be twice that of the angle ABC, and ABC was 0.927 radians. Angle is 2 times 0.927 radian minus half. Side 1 triangle was 10, side 2 triangle was 10 again, and sine of theta was 0.927 times 2 again, right? Plus pi r square over 2. Now this was the area semicircle of the smaller circle. So the smaller circle has radius 8. So pi r square, which is r is 8, over 2. So if we compute this, we get 145.22 squared centimeter, right? Now shaded area, back to the shaded area. Shaded area was area of smaller circle minus area of x. So the area of x is 145.22, and we'll need to find the area of the smaller circle. Smaller circle has radius 8, so pi r square, r is 8. Subtracted from minus 145.22, we get 55.84 squared centimeter. This is your area of the shaded region, this region. Alright.